In Lesson 10, you will have introduced the concept of atomic size, also known as measuring the atomic radius of the various atoms of elements on the periodic table. This activity will show your students in a very concrete visual way how atomic radius varies as you move across a series of elements on the periodic table. So as you go across a series of elements on a periodic table, and then also as you go down through a family of elements on the periodic table. Now in your teacher edition, there are instructions there for utilizing a sheet cake to conduct this activity. What you do with the sheet cake is take Twizzler licorice strands, little strings of licorice, and you lay them on the cake to represent the squares on the periodic table. Once you have that done, then you use toothpicks to show the relative sizes of the atoms based upon the chart that your students have in the student textbook. We have an alternative activity which tends to work even better than using cakes. Instead of using a cake, we're going to use a sheet of Play-Doh that you'll lay underneath an already printed periodic table. So the Play-Doh you used back in Lesson 2 can be utilized again, or if you didn't make the Play-Doh then, you can either use a container of store-bought Play-Doh or go back into Lesson 2 and find that recipe there for Play-Doh. One batch of Play-Doh usually makes enough for at least 2 students. So once you have your Play-Doh, you roll it out thin, at least to the size of your periodic table. And then you lay the table on top, making sure you've got some Play-Doh underneath where your hydrogen and helium elements are. Okay? And then instead of using toothpicks, we've found that dried spaghetti noodles work really well for this next part of the activity. So, what you'll have your students do is, starting with hydrogen on their chart, okay, the atomic radius for hydrogen here is 0.32 angstroms. Righty? If we compare that to helium, 0.31, and then if we kind of scan down the chart, we're not going to see any that are smaller values than hydrogen and helium are. Everything is larger than that. So with our spaghetti strand, since hydrogen and helium are the smallest, we're going to take just a small piece of spaghetti noodle here, and we're going to insert it right through the square for hydrogen there, and then we're going to take a piece just a little smaller, and we're going to stick it in the helium square through the paper into the Play-Doh. Okay, and that'll help anchor our page 2 as we begin. So now let's move on to lithium here. We go back to our chart, we find lithium, and the chart goes in atomic number order. So we're at lithium 1.23. Lithium's 1.23 angstrom. So this was 0.3. So this next one is approximately 4 times the size of that. So we're going to come up here, pretty good size. And lithium, we're going to insert that right there. Whoops, I broke it. Let me get another piece. So about 4 times the size of that will be about right there. And we'll stick it in right there for our lithium. Okay, so there's our lithium. Alrighty, now we're going to go beryllium is 0.89, so it's going to be shorter than the lithium one was. So I'll take another stick of spaghetti, and I'll kind of get an idea there. It's got to be a little bit shorter than that. So I'm going to stick my beryllium, still have it a little too tall, right in there. And again, go through the paper into the Play-Doh. Ready? So that's beryllium. We're going to come across to boron, back to our chart for boron, 0.82, a little bit shorter than the beryllium. Okay, so we'll get another piece of spaghetti, And again, I keep making them too long to start with there, so it's a little bit shorter. And there's our boron, and we'll stick it in there. And then next we have is carbon. Back on our sheet, carbon 0.77, so we're getting shorter. Okay, my spaghetti noodles aren't quite strong enough here. Let me go again. Stick that right in there. And then nitrogen is 0.74. So we continue a little shorter. Okay, and I'm going to go ahead and take the top off of it a little bit to show it's a little shorter. And then your students will just continue with oxygen, fluorine, and neon. And hopefully what they'll begin to see is, hey look, as I go across, size is going down. As we go across a series or period of elements, size goes down. So have them continue with the next series, starting with sodium and magnesium. Let's go ahead and look at sodium here real quick. Sodium on our list is going to be a little farther down. Let's see, where are we? Sodium 1.54. Now let's compare that to that lithium. Lithium is 1.23, sodium 154. So sodium is bigger in size than the lithium is. So let me get another spaghetti noodle. And we're going to make our sodium, probably not that big, larger than the lithium was. And we'll poke it through the paper into the Play-Doh again. Okay. And then if we continue with potassium, let's find potassium on our chart. It's right up here at the top, 2.03, so it's even larger than the last. So I'll get more spaghetti, and we'll poke again. Alrighty, and if we continue with rubidium and on down the chart here, your students can see, hey, wow, take a look at that. It's definitely going up. Size is going up as I move down through a family. So as your students continue, and on the chart we go up to xenon, which is number 54 right over here. If you have your students take their time and finish these, they'll definitely see this three-dimensional graph appear then. And as you go across through a series of elements, size goes down. As you go down through a family or group, size definitely goes up. Size goes up. You add layers of electrons as you go down, so size has to go up. As you go across, size goes down. Those attractive forces of the nucleus with those negatively charged electrons tend to slowly pull tighter and tighter and tighter in, and so the size tends to go down as you move across through a series or period of elements. So this is the alternative approach to this activity. We think it works a little better than the cake. It's a little easier to get set up, and then your students can quickly see the trends. If you'd rather do the cake, by all means, go ahead. Just make sure before you go to eat the cake at the end of the activity that you take all the toothpicks, or if you use spaghetti sticks, spaghetti noodles, that you do remove those so no one gets poked in the mouth with one of those. So this is lesson 10's activity, the Play-Doh atomic radius activity.